Okay, everybody, welcome. Welcome to this webinar on PreStress. I am very excited for this webinar because it will be a little bit special. Not only will I make a demonstration in PreStress and show how you can import a hollow core from an AutoCAD file and then perform a small calculation and check in PreStress, but today my colleague Pierre will also show PreStress working together with modeling software. So it will be kind of the future of prefab hollow core design. It's going to be very nice. I am also joined today by my colleague Frederick, and Frederick will help me with any questions that you might have. As you've already noticed, probably, we are using GoToWebinar platform for this webinar. There is a section called questions where you can go and type any questions that you have during my presentation. Hopefully, we will be able to go through all the questions in writing. Of course, after the presentations are over, we can also take questions live. If you have a microphone on your connected to your computer, we will be able to have a small conversation if you want to. You are able to raise your hand here in the GoToWebinar platform. There's a little button called raise hand, and I will see it, so I'll be able to grant you permission to use the microphone. So that's how we're going to do it. It's going to be really nice. Okay, so today we're going to talk about PreStress and hollow core design. For those of you who do not know me, my name is Flaviu. I am a structural engineer at StruSoft in Denmark. Okay, let's get started with PreStress. I'm going to start a new file, a new project. Every time I start a new project, I am prompted to select Eurocode with the national annex. We have some national annexes for England, for Britain, Denmark, Sweden, Finland, and Norway. I'm just going to select the standard for now and use it for my example. Here I'll enter a name. Let's see. Hollow core 101. A length for my element, and then I have to choose a section. For this, I'll go to this section database, and here's where I have all of my sections. PreStress can be used not only for hollow core design, but for pre-stressed elements in general, which are beams and hollow core designs and hollow cores. So I have a library of predefined profiles, and I have the possibility to also define my own cross-section. And for hollow cores, I will use the function called import. Now here is where I import a cross-section from AutoCAD. And I have here a file of some profiles. So let's say I have this nice file of all of my profiles, and instead of me starting to draw all of these profiles in PreStress, I can import them directly. So I just have this file. I will need to have this closed. Okay, changes to it. And then I go to import here, select drawing 2, click open, and PreStress will look into that drawing and find the sections that I am interested in. Of course, my recommendation is to have a clean a clean file in AutoCAD. And by clean, I mean just have the contour of your cross section and the holes. Those are very important because that's what PreStress is looking for. As you could see, my drawing was a little bit messy. I had all sorts of marks on it, of symbols, but I use that so I can show that you can also have it like that. PreStress will identify the profiles that are there, and it will also identify other small, which for me are in this case are useless, some small shapes. But what I'm interested in is the hollow cores, which I have them here, and that was really fast. I can just use them directly from the AutoCAD. I'll just give it a name. I have here the section parameters calculated for me. I gave it a name, and then I say import. Say OK, and my section is ready to use. So I have my section, and I'm ready to begin. I'll just click Add here, and I will make a fire load combination. Going to look at that too. This is the menu for my pre-stressed element. I have here the element with its span of 7 meters, its cross section here. And here is where I start to define my reinforcement and strand patterns. Very easily, I can define a reinforcement pattern. I have a default pattern, which is from PreStress, and it is also possible to create my own reinforcement pattern. I have created one beforehand for this element. As you can see, I have some coordinates for my strands, and I can use this pattern for future projects as well, if I want to. So it is easy for me now to just select my points. So I want strands in there. Just like that, I just click Add, and my strand pattern is added. Of course, I can customize it, remove any kind of tendons that I don't want, or reposition them. I can also do that manually from the coordinates here. Set up the diameter of the strands and have a pre-stressing force here as well. So I can do that really easy. Here is where I have my reinforcement details, where I set the covers for my strands, calculation settings. Here I have some specific checks for hollow cores, which I can make. I can check for splitting and spalling, and I can perform a punching check according to Eurocode 1168, which is specific for hollow cores. Here I have a short info window where I can see what this does. What these options are for. I can set some shear calculations, parameters, SLS settings. I have my fire calculation here. I can choose where my fire comes from, fire duration. Then I have calculation settings, sections which are set by default in this manner. I can also add and delete my own. Okay. I have my strand pattern here. Another feature for hollow cores is the edit, recess, and core fillings. I can have a core filling and fill up one of those hollow cores. Let's say I want to do the third one, start from X, and have it for 2000 millimeters. I'll just add it there, and I have a filling. And for the recesses, I can also enter these coordinates. Now I want the height to be 150, length 800. So I can see that I have a filling and a hole. So I can add these wherever I want on my element. Yes, when I'm done and I'm happy with my reinforcement layout and my recesses and core fillings, I'm ready to go to the loads. I already see here that I have the different stages of my element, from the release till final stage and fire. Go to input loads here. And I can see that the self-weight is already added to my element. What I want to do is create some more load cases. I'm going to add screed, which will be permanent load. And then I'm going to add some office load. And I choose here the type. This type is important because this will determine the coefficients for the load combinations when I will generate them automatically. So I have some loads, some load cases. Click OK. I choose the load case that I want to add loads to. And I'll just add some loads. I have here uniform load. And then the value that I want, I enter it there, and then I assign it to the stages that I'm interested in. And the same I can do for the office here. For the office, I'm going to use, again, a distributed load. Start applying it. I also have the possibility to enter a eccentricity. So I can add this load with the eccentricity if I want to in millimeters. And I also have the option to place a point load. Let's place it. I want it to be two meters from the left side. I have here the eccentricity as well, and I'm going to put it 0.3 again. And then for punching, I will need this base on which the force will be distributed on for the punching check. So I can also actually see here, I need this in millimeters. I can see where the force is acting. According to the centroid, and then I have a base there. Okay. And then I place it, of course, just to show you that it is possible to do this. So I can check my loads. And see that I have see an overview of my loads for all of my load cases. See here a nice distribution of the self-weight according to my recess as well, my hole and the hollow core, and the other loads that I created. Great. Okay. Now I'm happy with my loads. Let's make some load combinations. As I was saying, it is possible to create them automatically. So for each load, for each stage, I just select it and then choose the little cases that I want and click on change. And the coefficients will automatically be inserted there. So I don't have to do anything but to choose the cases that I want in my load combination. And I'll get the correct Eurocode coefficients. Of course, I'm able to edit that and enter my own coefficients or change this equation here, this combination, accordingly. Also have long-term parameters, which I can enter for creep and shrinkage. Study the long-term effects. For now, I'm going to make a calculation. Analyze. I get a warning here about my cover. It'll still make the calculation, but it just warns me that the cover needs to be according to code. So I have to check that. Again, if you have any questions, feel free to type them in the question sections. My calculation is over now, so I can check my results. I have here moment, and I have an overview of all of my stages. I get some torsion too, as I've made some eccentricity. I have a shear force, axial force, if that's the case, and then deflection. Then I can go to design and do a code control. I get an overview of my utilization here in the results for the design checks. So I have this graph here which represents utilization. If it's green, then that's fine. When I get these red areas, I know that there is a problem there, so I can easily identify it and see what it is. In the storage and maturing, I go to results, code check, go to storage and maturing. So I can see that I have some compression stress, which is above my limits. A little bit in this case, but the point is that I can actually identify what my problem is straight away and go and correct it. So I really like that. And I can check the verifications and see the checks it makes for each of the stages. I have here spalling as well, the verification for the hollow core. I have here a temperature gradient for the fire. Everything that is below this line is a damaged portion. So I have here a damaged portion which is ignored because of the fire, after the fire effects. So after I'm done with my calculation, and I'm happy with it, I can use this print option and get my documentation report ready. All of the calculations and input data, cross-section, material properties, load combinations are included in this report, together with the results for each of my sections, for each of those construction stages as well, and moment capacity checks. It'll generate me a report which will consist of some pages here, so I'm just patiently waiting for it to finish. So I can browse here through the documentation report and see all the results, eigenfrequencies, and then the stresses for each of my section here. For all of the load combinations. Reduction due to fire. Shear capacity, and then that's it. So everything is step by step. It's pretty much very oriented towards, in this case, pre-stressed hollow core calculations. You can do also beams, as I said in the beginning. So it is pretty direct, very focused on calculating, verification, and report. Okay, I'm going to check my questions here, and Frederick. will be on them. Yes. Okay. And now for the cool stuff, I am going to hand over the screen and microphone to Pierre. Let me just find him here. Okay, Pierre, whenever you're ready, you have the floor and option to share your screen.
All right, so I'm unmuted. All right. Okay, so my name is Pierre, and I will show you guys the next step we're doing in PreStress. So basically, we are connecting to. Let's see if I can minimize this. I get my screen. Okay, move it down here then. This is a connection between our modeling software and design software called Impact. I guess some of you are familiar with it. It's not really my area of expertise, but basically in this module you can do the planning, you can do the design of a building, you can do transport planning, cost planning, doing drawings, of course. So basically you start in a modeling software like AutoCAD or Revit or PreStress actually, and you will have special functions for doing like a special wall or an hollow core or something like that. And then you can build your model and it's saved to a database. And this is basically the big thing. The whole project is saved in a database with its parameters. So this is what we're using now. So outside of the calculate or the modeling software, there is a general product manager view, and this is what we're looking at now. So basically, if you see in the left side of my screen here, we can see this particular model, which is a test model, and it has comprised all the components available in this model. And for example, it has 6 floors. And if you open up, see floor number 5, you see there's a lot of hollow cores. It's the top floor we see here.
Pierre, sorry to interrupt, just one question. So if I understand correctly, you can actually take a model from Revit or Tekla or whatever modeling software you use and open it with Impact here, basically directly.
Yeah, basically the base Impact design suite as such is it's a set of tools basically working like a plugin into these design programs such as AutoCAD or Revit. And like for example, there could be like an option, draw wall, for example, and you push it, and it would draw a wall with all the little indentations and all the casting goods that you have set in your standard. So this is a very big application with a lot of bells and whistles.
Right.
But you can also do like just simple geometry, and then you can save that in a database, and you can open it in this product manager we are looking at now. So what I'm using now is the fact that someone has already drawn hollow cores, for example, at the top of this building. So there's like a profile, there is a strand pattern, and there are measurements and whatnot. So what I'm doing now is basically saying, okay, I want to do a fast check on this on this particular floor. So I just choose my floor, and as I open it in the calculation view, it will zoom in and give me a two-dimensional view of that particular floor. And here we see all the hollow cores. And I have a special tab for calculation purposes, which is this is like I should mention this is a project under development, so this is the first beta version, so it's not feature complete yet. So what you see here now is all the hollow cores on that particular floor, and I can, for example, choose one and click on it, and I'll say I will do a calculation on that one. So I have a few options here to do. Just a simple calculation button, but there's a few settings to be done. First and foremost, you realize there are really no loads. So what we have done here is a very simplified load module, not really as advanced as you see Flaviu show you in PreStress. It will do a simple load with just one imposed load and a dead weight, basically, and do a ULS, ultimate limit state check on it. So if I open up this chooser here, I can see there are certain template loads I can choose in terms of imposed loads. So this is just to get you started, basically. So let's say I say it's rooms in a residential building. And I can also choose the concrete quality, because as it is right now, this is not possible to choose in the database. So this is something we will be adding in a more general way in the future. It basically just says concrete or not concrete right now. We need equality. So that's it. So then I'll just say start calculation, which will start a gathering process from the data.
Hi, Pierre. Okay.
Okay, I'm back.
Yeah, good, great.
Okay. Just when I was kicked out from the server, I was muted. Some sort of divine intervention. So let's try that again, shall we? We did a calculation, that's right. So we are gathering data from the database. And it will open PreStress and actually fix on a breakpoint in my developer tool. Let's skip that and go forth. So there you saw PreStress jumping up. PreStress is installed in the background, so it will actually start PreStress for you, feed it with a file, wait for it to calculate, and then get some results back, and then you can see the results of that in the project manager. There's also another one. Let's skip that. This is just my developer tool going in debug mode. So there we have it. Now we have made a calculation. So if I just click to release the selection there, you can see that this element actually got a color, and you see also there's a little dot here. So that basically means this one is green, this one has the utilization ratios below 100%. So if we check the calculation report, we see this should be a better picture in the future, but what you see here is the same report basically you see in PreStress called the overview report, which give you the highlights of the ultimate limit state cases. So what you see here is I've hard-coded in a final stage 610A and 1610B. So it will check them both and see which one is the worst. And I suppose the screen is too small for you to see, but I can say to you that none of the utilization ratio is over 1. So this means it's okay. Would it be over 1, then the calculation view would have showed me a different color, red in this case. So in this way, you can get like an overview of which elements have or have not been calculated. As you see here, these gray ones have not been calculated yet. And the ones that has been calculated has a calculation status being okay or not okay. And that's the base calculation function with this simplified load module. The next step of this iteration will, of course, be expanding the load handling for the whole project, being similar to the one that Flaviu just showed you. And also, I could mention that you can actually do like a half and half or half-baked thing. You can select one and you can say open in PreStress. So that will will extract all you need from the database, and it will open PreStress for you with the information that it has, and then you can continue to do what you want. So what you see here is what I would have been calculated before. That you get a chance to get in there and maybe do some changes or something, and then you can continue to calculate. And when you're done, you can save in PreStress your custom calculation, and then you can actually import it back into PreStress if you want to do some sort of custom special thing. And then that result is attached to that element, and it will of course still check if it's green or red or whatnot. So that's basically it for what we're doing now. Of course, this is the first iteration of this calculation module, and we will show it again on the user days in November. It will be part of version 16 of Impact. And yeah, that's basically it. Yep.
Thanks a lot. All right. That was great. Thank you, Pierre. So it's nice to see. It's nice to see these PreStress as itself a very powerful tool for calculating pre-stressed and prefabricated beams and slabs, also working as a component of a larger system. It's really nice and interesting to see, and how the whole process is evolving, and the way that engineers design and calculate and check. It's really interesting to see. I hope you really enjoyed it too. If you're interested in PreStress, if you're not using it already, you are more than welcome to let me know about a trial license. I can activate a trial license for you, and you can test it for yourself and get started. I will be here to help you with intro courses and any questions that you might have. You can also apply for a trial online if you go to our website, which is here, strusoft.com, and then go to products, PreStress, get started. And here you can apply for a trial license and fill out the form with your email address and phone number, and then you can get access to a trial for PreStress. Again, thanks so much for attending. If you have any other questions, feel free to contact me on my email address, or just give me a call on this number. I'm located in Denmark, so make sure to put the country code here, +45. And I'm always available for a chat and questions about PreStress. All right, I'm going to end the webinar here. Thank you so much for participating, and hope to hear from you very soon. Have a great day. Bye.